Today we're going to try some scale model problems, and some of them are pretty challenging. So let's give it a try. Our first problem says a model building was 15 inches long. The scale for the model was 1/4 inch for every 20 feet. How long was the actual building? So we just need to find out how long the actual building is. So I'm going to draw some pictures. All right, so I drew a model house. So here's my model. So that's the small version, and it's 15 inches long. So I put that in from the problem. And then my real house, or the actual building, we don't know how long that is. That's what we need to figure out. So I'm going to use the scale that they gave me in the problem to figure that out. All right, so here's my scale. 1/4 of an inch for every 20 feet. I'm just putting 1/4 of an inch on top, 20 feet on the bottom, just how I'm reading it. The scale you can just put in any order, but 1/4 of an inch per 20 feet. All right, now I'm going to fill in the information from the problem, being careful that I put inches on top and feet on the bottom. All right, so I filled in for 15 inches. The model is 15 inches, but how many feet is that? Now I can solve by equivalent ratios or cross multiplication. So let's see, 1/4. Can I figure out how to get from 1/4 to 15? I can't, so I'm going to use cross products or cross multiplication to solve. All right, so now I'm going to multiply 20 times 15 and 1/4 times x. So 1/4 times x is just 1/4 x, and that equals 20 times 15. Well, if I cover up the 0, 2 times 15 is 30. Then I'm going to add a 0, so 20 times 15 would be 300. So now I've got to get x all alone. So to get rid of 1/4 or make that 1, I'm going to divide by 1/4 on each side and divide by 1/4. So now I just have to, just one second. So now 300 divided by 1/4. Well, I'm going to write that out horizontally. 300 divided by 1/4 is just keep, change, and flip. So 300 over 1 times 4 over 1, 300 times 4 is 1200 over 1. So my answer is 1200, and that goes in feet. So my real house or building is actually 1200 feet long, and that answers my question. All right, second problem. And this one I want you to try on your own before you watch this. So at the Kennedy Space Center, a rocket was 2,160 feet tall. A model of the rocket was created using a scale of 1/2 inch to 80 feet. So how tall was the model rocket? So this time they're giving us the height of the actual spacecraft or the rocket and want us to find the size of the model. So I'm going to fill in my picture. All right, my drawing. So my real rocket, or my actual rocket, is 2,160 feet tall, and it's asking me how tall was the model rocket. So that's what I need to figure out. And I'm going to use the scale to help me figure it out. 1 inch equals 80 feet. So I'm going to write that into a ratio. All right, so I wrote my scale here, 1/2 inch over 80 feet. That's my scale that I'm going to use to figure out my answer. So then I'm going to put the information from the problem I know. Well, I know that the real rocket was 2,160 feet tall, so I put feet across from feet, but I don't know how many inches. So I'm going to solve. By cross multiplication because I can't figure out the relationship here. So I'm going to solve by cross multiplication. All right, so 80 times x is 80x, and 1/2 times 2,160 is, if I did that on the side, 1/2 times the whole number, 2,100, that is so messy, is actually that number divided by 2, where the answer would be, so 1/2 times 2,160 is 1,080. You can do that on your calculator too. So let's solve for x. I want to get x all alone, so I'm going to turn 80 into the number 1. 80 divided by 80 makes it 1. So whatever I do to this side, I have to do to this side. So I'm going to divide by 80. So this becomes 1. So x equals 1,080 divided by 80, which is 13.5. I just did that on my calculator. So 13.5. So the answer to my problem is that the model rocket is 13.5 inches. So the answer, how tall was the model rocket? 13.5 inches. All right, problem 3. And this problem gets a little bit harder. So the scale drawing of a rectangular patio was 4 1/3 centimeters by, or 4 1/2 centimeters by 2 1/2 centimeters. The scale used was 1/2 centimeter equals 3 meters. If a fence costs $20 per meter, how much would the fence around the actual patio cost? So they gave us how big the patio was on the blueprint or on the drawing. So, and they gave us the scale. So we need to find out how big the actual patio was. So then we can find out the cost of the fence. So let's just do it step by step. I'm gonna just draw my models first. All right, so I've drawn my models. This is the scale drawing of the rectangular patio, and I just, instead of 4 1/2, I just wrote 4.5 centimeters, because 0.5 is equal to 1/2, so I thought that might be easier to deal with. So 4.5 centimeters, and then 2 1/2 centimeters, I wrote 2.5. And then what we need to figure out is how big the actual patio is, so the length and the width of the actual patio. So I went ahead and used my scale. 1 1/2 centimeters equals 3 meters, and I, instead of 1/2 centimeters, I also changed that to a decimal and wrote 0.5 or 5/10 centimeters right here per every 3 meters. All right, so now I can use the scale to figure out my missing pieces. So I'm gonna do that. I have to do that one by one. So I'm gonna start and see and put this side into a ratio and see if I can figure out the missing side for the actual patio. So 4.5 centimeters would equal how many meters? Well, I'm going to use the scale to figure that out. All right, so I'm going to fill in 5.5 centimeters on top. Oops, that's a decimal there. And we don't know how many meters that would be, but I can use my scale right here to figure it out. So I'm going to do cross multiplication to figure out what x is. So 5 times x is 5x, and that will equal whatever 3 times 4.5 is, which is 13.5. So actually this is, oops, sorry, 0.5x. So now I'm going to solve for x. So to solve for x, we want to get x all alone. So we want to turn 0.5 into 1. So I'm going to divide by 0.5 on this side and divide by 5/10 or 0.5 on this side. So when I divide 0.5 by 0.5 or 5/10 by 5/10, that just becomes 1. So I'm left with x on this side. And then 3.5 divided by 0.5 would equal 27 if you did that on your calculator. So again, that's 3.5, and the fraction bar means divide, so divided by 0.5 or 5/10, and that would equal 27. So our first side of our real patio is 27 meters. So I'm going to go ahead and fill that in. Now I'm ready to figure out the second side right here. So I'm going to use 2.5 centimeters and use our scale to see how many meters that would be. So if our scale says 0.5 centimeters for every 3 meters, so I can set that ratio equal to, well, what would 2.5 centimeters be? How many meters would that be? All right, so now I'm ready to solve, for x. All right, so we're going to cross multiply. So I can say that 0.5 times x is 0.5x, and that equals whatever 3 times 2.5 is. And 3 times 2.5 is 7.5. So now I've got to solve for x, so I want to get x all alone. So I'm going to divide by 0.5 to make whatever's with x1, and divide by 0.5 on the other side, or 5/10 on the other side. So x equals 7.5 divided by 5/10, and that would be 15. So that tells me how many meters I have on the other side of the patio. All right, so now I know all the dimensions of the actual patio, and now I have to build a fence around it and find out the cost per meter to buy the fence. So it says $20 per meter. So how many meters goes around the actual patio? Well, that's a perimeter problem, not an area problem, perimeter. So I need to add the sides. So I know I have 15 here, and 15 would be on the other side. So 15 plus 15 plus 27 plus 27, because 27's here, 15's here. So I'm going to add all the sides, and I will get 84 meters for the perimeter. So 84 meters, and then I just have to multiply my meters times my $20 per meter. So times $20, and that will be my total cost. So my total cost to put the fence around the actual patio is, let's see, $1,680. So 84 times $20 is $1,680. So that is the answer to this very long problem. Problem 4. I've set some of this up for you. So the scale drawing of a rectangular deck was 3.5 inches by 1 3/4 inches. The scale used was 1/2 inches equals 3 feet. So I wrote the scale here. And here is our scale drawing. So the little scale drawing of the deck, like a wooden deck that you'd have outside your house. So 3.5 inches by, that's the length, by the width, 1.25 inches. So they want to know if the wood for the deck floor costs $5 per square foot, how much would the actual deck cost? Well, we need to find out the measurements of the actual deck first, and then it looks like if we're finding, we need to cover the deck. Covering is area, so we'll need to find the area after that. All right, let's get started. So I have the scale here, 1/2 inch to every 3 feet. So I can, if the model says 3.5 inches on the scale drawing, then I need to see what that converts to in real life. All right, so I'm going to write 3.5 inches here over, we don't know how many feet. So we can solve this using these ratios and cross multiplication. So I am going to multiply 1/2 times x and 3 times 3.5. And I'm actually going to change 1/2 to 0.5 to make it easier. But you can keep that as fractions if you want to. All right, so 0.5 times x is 0.5 x, or 5/10 times x is 5/10 x, equals 3 times 3.5, and that is 10.5. So now I need to just solve for x. So I'm going to divide by 5/10 to get x all alone. So 0.5 divided by 0.5 turns that just to 1. And I've got to do the same to the other side, divide by 0.5. So now x equals, I'm going to bring this up here, and x equals 10.5 divided by 0.5, which is 21. And that would be feet. So I've got my first measurement now, 21 feet for one of the sides of my deck. So I just filled that in here. So that's that side. Now we've got to figure out the other side. So I'm going to use my scale to figure out the other side now. All right, so here's my scale again. 1/2 inch equals every 3 feet. So 0.5 inches equals for every 3 feet. And I'm going to now fill in my other side right here. So if my model or my scale drawing has 1.25 inches, how many feet does that convert to? So how many feet would be my other side? So I'm going to do, again, cross multiplication. So 0.5x would equal whatever 3 times 1.25 is, and that is 3.75. So now I'm going to divide by 0.5 on this side to get x all alone. Divide by 0.5 on this side. I'm going to rewrite up here. So that turns into 1. So x equals 3.5 divided by 0.5 is 7.5. So that is the other side. So that goes here. So 7.5 feet, which I'm going to rewrite in my draw. All right, so I have figured out the actual length and width of my deck floor. So now I just have to figure out how much the deck floor would cost per square foot. So the floor would cover the deck, so I need to find the area. So area is length times width. So 21 times 7.5 would give me the area of 157.5 square feet. So now if that is my area, and I know from up above that it cost $5 per square foot, well, I'm just going to multiply this amount times $5. So I'm going to multiply 157.5 times $5, and I will get a dollar amount of $787.50, and that is the cost of my deck floor.